The goal of the game is to pop as many balls as possible. Tons of bragging rights if we can get at the top of it. You do not trust the client. They finally verify this with the final tests with the help of a little Python script. And it's not in the right order, no! Since the dawn of time, humans have compared themselves against each other through simulated competition and through the natural game of life. But in the last century, we've been able to compete in a way never before dreamed of. High scores are a timeless achievement of proving that you're better than anybody else, and they've existed since the beginning, often as incentive to keep playing the game and get into the feedback loop of entertainment. But with the invention of the internet, it's been possible to share high scores with the entire world. There's only one massive problem. How do we keep people honest? Hello, and welcome. I'm Developer Doge, a computer scientist and indie game developer. Come spend some time with me as I discuss hacking the leaderboards, a lesson in game development. Today's discussion needs only a little backstory. Previously, I reviewed libGDX Game Jam 18, as well as submitted an entry to it, with the help of my partner for that jam, James. But something mysterious happened before the jam. James's leaderboard for his previous jam game was claimed to be compromised by Doge. Was this true? Was this possible? Let's investigate. The theme of the game jam we're looking at was called Balls, a fan favorite for sure, as it still gets brought up every new voting season. As for the specific entry we're looking at, it's called Unipop, from Java Cake Games, or rather, as we know them, as a person named James. And we can see that they have this phenomenal leaderboard down here right below the game. Currently, iCarly is in the lead with 181. Let's see if we can beat their iScore. What is your name? Today we will be Dinkelbergs. Let's try this out. So as with many of my reviews previously, I've actually played this before, and I'm gonna quite genuinely try to get a high score here. There's two types of balls that fly in the air, volleyballs and 8 balls. 8 balls will snap your unicorn's horn off like a twig. The goal of the game is to pop as many balls as possible. You may ask, why don't I just go to the hide in the edge? Well, it's because of that right there. Your unicorn begins cooking if you spend too long in the edge. And if you spend too long on fire, you will lose the game. Oh, so many 8 balls at once, wow. I wonder if this actually doesn't get more difficult over time. It's turned from hacking the leaderboard into speedrunning. Speedrunning the high score. This is actually... Oh, what is happening? What is... Oh. 160? Wow. Alright, now, the people who got these numbers are definitely skilled and dedicated players. They put their mind to it. And it's important to note that some of the people under iCarly are people we actually know from the libGDX server. We have Zeroed, DinoSage. Oh, Dinkelbergs is up there, so that's actually my high score that I just got legitimately. Grox, Red Sponge, Tommy GDX, James GDX. Bob is here, Haze Dev, Spark, Sprack, Max, Pan, Aurelius, Mike. These are lots of respectable names to beat. So this leaderboard has tons of bragging rights if we can get at the top of it. So I think it's time to get to business. So how do leaderboards work? There's probably an infinite amount of ways to actually create a leaderboard. We want to find out how this one works. Usually we can use the networking tab, but James has made it exceedingly easy for us as he has open leaderboard in new tab, which directs us to api.javakickgames.com. And we can see here that this is our entire leaderboard that we are seeing from this page. Now, the extremely important part. Unipop is an offline game. Everything happens on my computer, locally, in the box that is physically beside me. I then tell JavaKick Games what my high score was through an HTTP request. And this is an extremely difficult model to secure. This is an age-old thing that's happened before with your first MMOs and the first multi-user dungeons. Ever since they were invented, it's been known you do not trust the client. The client can say whatever they absolutely want to, that they have more money than they actually do, that they are in a different position than that they actually are. You cannot trust anything that they say. And so we are able to simply tell the server something happened. This is the path that we are going to take to attack these high scores. Now, let's find out what this HTTP request looks like. When we play the game, we are going to have the networking tab open. And then as I play the game, I'm going to lose and see what the high score request looks like. And so to the server, we are going to be perfectly genuine. We are still this user called Dinkelbergs, but maybe we'll be someone else for now. We'll be Dinkelbergs1 for this test. And so let's get 2, let's just get 4. And then, oh, we actually see it down there. We see it already. So at the bottom, we can see that there is a post request sent to api.javakickgames, and it's to set score2.php, and we can actually look at the request and see that there are 3 pieces of information being sent. So we can identify them. N, Dinkelbergs1, that's the name. S is 4, and that's the score. And there's this third thing. What is that? Very interesting. But for now, we will leave it. We will now execute the attack and send them bogus values. So that is very, very easy to do in here. We can actually edit and resend, and all we want to do is in the body, instead of saying our score was 4, let's say our score was 400. That's way above anybody on the leaderboard. Let's see how it deals with that. We got a 402 payment required. What? James, you legend. It was this that inspired me to continue poking around. What a cheeky response. Payment required. It's not like it was really handled. Nothing popped up and asked for my payment. But James wrote the server to return a 402. And the server knew I was cheating. How did that happen? So I think that the third value in this request is actually extremely, extremely important. We really have to know, what is it? Where did it come from? We are going to continue to use the debugging tools, except we are going to use one more tool, and it is called XHR Breakpoints. Now, XHR is XML HTTP request, And that's how your web browsers send and receive any kind of information behind the scenes. While you're already on the page, your browser can use an XHR request, or R is request, so it's an XHR request. An XHR, you can use an XHR to do that. And so I think it only submits when we actually beat our high score. So let's do that. Our current score is 4. And so we just need to get more than 4 to maybe trigger this. So let's do this. 1, 2, 3, 4. Let's get 5. Okay, let's intentionally do, and it worked. Perfect. We can see that we are now suspended in debug mode. We can have a whole look around the current stack on JavaScript, what the browser has been doing. And we can see all the variables in scope. Looking at the code, we can clearly see that it's obfuscated. But we know that this is not done intentionally. This is because in libGDX, in order to create a game for HTML, it uses a tool called GWT, or Google Web Toolkit. And what it does is it takes the source code of Java and it cross-compiles it, or it transpiles it into JavaScript. And that's the JavaScript that we see in front of us. And so these variable names are all generated. But in the code, we can actually see something we recognize, h.send. And in the scope, h is an XHR. Let's see if we can go up the stack and follow where this value came from, this mysterious H value that we're sending to the server. Let's take a step. And it's just so maybe it's a constructor for the XHR, but we can see that our value is just being passed in, not created here. So let's take one more step down. And this is maybe some kind of utility method, because we can see some error checking. Can't process an HTTP request without URL set. Unsupported HTTP method, and we also see that our value has already been passed, so not created. We need to figure out where it's created, go down one more step, and we see some things that we recognize. First, we note that there is actually an authorization header, and it's being set to javacakegames.com. That's something that we didn't notice before. But secondly, we see 3 values that we already know about. We see N, S, and H. And if we go to the networking tab, we can see that these are the 3 values that we send to the server. N being the name, S being the score, and H being this mysterious string. And so just based off intuition and just this naming scheme of the form data, N being the name, S being the score, I'm prone to believe that H is actually hash. But for now, we can see that H is simply the result of this function, this mysterious function FEE. It takes in this A object, which is maybe this big, it's like the context. That has a lot of stuff in there. I don't think that's and then it takes in a very nice long string concatenation, we see. So it takes in our score times 9, and then concatenates our name, and then concatenates the user agent. And so if we want to look at this FEE function, I thought that you could just jump with that button over there, but that just leads us here. My next idea was to check the actual code of the game and Control F for function FEE. And we can see one result here, but that does not match our capitalization. And our next one right there, this is where the function is declared. However, I don't have any syntax highlighting. There's no jumping to functions. So this isn't something that's going to help us very much. We can head back over to the console now, because we actually know everything that we need already. We know that 1, there's an authorization header and it's being set to JavaCake Games. We know that we send a body with N, our name, S, the score, and H, the weird H value. And 3, we know that H is the result of calling this function, FEE. So we actually note in our debugger that FEE, when we use it, it takes in two arguments. It takes in the A super object, but then it takes in the really long string concatenation. So armed with that, let's set this up. In the console, we are going to say var test super object. Horrible names, but I don't want to step on any of these other random generated names. That's just going to be an empty object. That will represent that weird A thing that gets taken in. And next, we have the string concatenation. And what that consists of, as we said, and then the string concatenation is our score times 9 that we saw in the source code. So I'm going to pretend our score is 1. I'm going to start it in a 9. Then we add our name. Our name, let's add something, a name. And the next is the string concatenation of our user agent. And so I am just going to grab that. Make it all one string because it's all concatenated into one string. Perfect. And then for our test, result equals FEE, and it takes in test super object, and it takes in the test string concat. Ooh, and we see that we actually have an error. We see that B is undefined. And this is a bit of a problem. So it makes me really wonder what was really happening at this part, at the FEE. But we see that they just pass in this mysterious A object. So we are actually just going to imitate that exactly. We are going to pass in A. And our test result is a string that looks suspiciously like the same strings that we provide James's server. Now, let's actually finally verify this with a final test. We will edit and resend our last body, but we have to use the values that we created so that it would work. Let's set this up. Our name was a name. Our score was 1. And the hash value is this value right here. And we are gonna get the hash, slap it in there, and then we are gonna send this. And we can see that we did not get the 402 payment required, but we actually got a 204. And for the final test is if we go to once we got to stop the debugger, and then if we go to his leaderboards, and we should see a name. This is huge news. After I managed to get on the high scores, I talked to James about it later. He confided in me with the actual source code of the client so that I could see, unobfuscated, what was actually happening. We see that our multiplication of 9 was actually bang on. And the idea that the string is a hash is completely correct. Except for, in many security libraries, they call it a digest, but it is still a hash. I previously located this reference to the SHA-256 algorithm in code, but the part that I was unable to figure out because I had to read through the GWT code, which was very obfuscated and I didn't see it, was that the digest or the hash that gets sent is base 64 encoded with the last character removed. If I had a little more experience, I would have been able to recognize it just from seeing that all the characters that are in the string, it's not JSON. It probably is base 64. Either way, this was a great learning experience. So with this knowledge, we can demonstrate that high scores are completely unsecurable. And we will be performing this with the help of a little Python script. First, let's confirm that Python can do the exact same thing as JavaScript. Let's use SHA-256 to get some bytes and then compare them against each other. So I have this example right here where in JavaScript I pass the fee function the string of crinkle. So we're going to try to imitate that exactly in Python with this code right here, where we grab crinkle, encode it, and then pass it through the SHA-256. And so we're going to run that, and what we're looking for okay. And we're looking for hash to very similarly match that. And we're gonna run Python 3 test.py. Yes, and so that is exactly what is happening. It's SHA-256, and we can even do this in Python. We do the silly little thing where we remove that last character of padding, and so then this will work. So I've prepared a script that will. I've prepared this script that will use onto James's server to get everybody to subscribe. And this is going to be the final test. And so we have the moment of truth. And if we go to the high scores, we can see subscribe to PewDiePie, and it's not in the right order. No. Thank you so much for spending the time to watch my video. Thank you so much to James for creating such a crazy adventure to go through. And thank you to a whole community that encourages people to create software like this, to practice and learn, and in hopes that it'll be useful in the future. I hope all of you have a great day and take care.